So our next pattern is Cqrs. Yep, that's quite a funny name, but the pattern is sound, I assure you. So what exactly is Cqrs? Well, Cqrs stands for Command Query Responsibility Segregation. What it actually means is this. While in traditional systems the same database is used for retrieving and updating data, in Cqrs-based system these are separated to two different databases, meaning we have one database for storing data and one database for retrieving the data, and some kind of service to sync between them. Now, on first thought, that might sound strange. Why would we want that? It's much more logical to retrieve and update the same data from the same database, isn't it? Well, sometimes it is, but sometimes not so much. Let's take a look again at the event sourcing pattern. As you probably remember, with event sourcing, we do not keep an entity's state, but rather add events that happened to the entity. This enables us an extremely efficient tracing, simple data model, and great performance. On the other hand, it makes our life harder regarding data retrieval, since we do not have a unified view of the entity and we need to go through the entity's events to gather its states, which is a slow and cumbersome action. The Cqrs pattern helps us solve exactly this. With Cqrs, we have the event sourcing data, which is stored in database A. Once in a while, usually a few seconds, the data is gathered and stored in database B, where it represents the entity's state. Note, the data in both databases represent the same entities but in different formats. Database A is used for updates and does so with event sourcing, which gives it great performance, and database B is used for retrieval and contains the full current state of the entities. So now we've got the best of two worlds, great performance for updates and easy querying capabilities. All this is made possible by the Cqrs pattern. Okay, so if all is so good, why isn't the Cqrs more common? Why don't all architects use it all the time? The main reason is simplicity. In order to implement Cqrs, we need two databases, synchronization engine to gather the data from database A, transform it and store it in database B, and event sourcing mechanism. Implementing all these can be quite complex and not always necessary. If you are satisfied with the current single database implementation, keep using it. So when is best to use Cqrs? Mainly on systems with high-frequency updates that require near real-time query capabilities. Think again on telemetry systems. These systems usually get a lot of data and need to handle it as quick as possible. This is a great candidate of Cqrs implementation. So that was a short glimpse of event sourcing and Cqrs. You may never use these patterns, but it's always a good idea to keep them in mind.